Yes. So in the previous classes, we finished with a chapter of symmetry and congruent figures. And today we are going to start with a new unit that is known as mensuration and statistics. Okay. In this, we are going to do area. Okay. We are going to do volume, that is also capacity. And then we are going to do stats. Okay. Statistics. Then from this the chapter from this unit. The first one is the 16th chapter, that is area of a plane figure. Yes, Abraham, your hand is raised. You want to ask something?
No, but there is a new study the art theory is the best of the concept of the computer.
I cannot really hear that, Abraham. Voice is muffled. We have area of plane figures. Now, in our daily life, sometimes we, like when we grow up, we need to find the area of a particular place. Okay, suppose the area of a plot or the area of the four walls of a room. Okay, or to find the length of the boundary of a square shaped or a circular or rectangular part. Okay, to find the perimeter. So all these things we come across them in our day-to-day life. Okay, so similar things we are going to learn in this chapter. Okay, we are going to learn how to calculate the area and perimeter of different types of figures. Okay, what is area, what is perimeter, their meaning. All right. So this chapter is going to give us a conceptual understanding of perimeter and area of plane regions. Okay. So let's understand what are plane regions. Now, if I have two figures, suppose over here, suppose I have two figures over here, A and B. Now, can you tell just by looking at which figure has larger region? Can you tell by looking at them that what figure has larger region? Yes, yes, that's right. A figure has larger region. Okay, the region of plane covered by A is larger than the region covered by B. Okay, but there are some figures, okay, which we cannot just tell by looking at which region is bigger. Suppose again we have two regions, okay, E and F. Can you tell by looking exactly which region is has the larger area? No, right? They kind of look similar, right? So now when we cannot tell which has larger area, we need to calculate it. And also to know the exact area, okay, to know the exact area, we need to calculate the area. Okay. So then also we calculate in this chapter, since we are going to learn, we calculate area of a plane region. Okay. Now, can you give me some examples of a plane region of plane figures?
Now, another question.
Yes, Abraham, ask.
Because you are going to pentagon, it's actually very calculated area now. Remember, how do we calculate the area of a shape without any lines and it's just basically squiggly?
How do we do that, Abraham? What is done is when you are having an irregular shape, okay, without any lines or something, people they divide it into shapes, okay? They divide it into shapes. Like okay, look at this. Like they have an irregular shape, okay? What do they do? They divide it in 1 second. A rectangle, okay? It's divided in a rectangle, in a square.
Because you cannot find the actual area, you can only find the approximate value.
Yes, when the actual area is difficult to be calculated, we use the approximate value that is close to the actual value. Okay, it's very close to the actual value. They divide it into shapes such as squares, rectangles, and circles. Okay, and then they take the approximate value of it all. Okay, so yes, I was talking about plane figures. Now, when we talk about plane figures, they are the figures that are made up of line segments. Okay, figures that are made up of line segments or have a plane surface. Okay, like like a triangle, like a rectangle, like a square. Okay. Also, these figures are known as rectilinear figures. Okay, why? Because they are formed by line segments. Rectilinear figures. Okay, 1 second. You can write it down. Plane figures such as triangle, square, rectangle, etc. are called rectilinear figures because these are formed by line segments. Okay. Now, also, these rectilinear or linear figures are also called simple because its two sides, except the common point, they never meet each other. Okay, its two sides, except the common point, they never meet each other. Now, I'm drawing two shapes again. Look at them. Let's name them A, B, C, D. And this one, A, B, C, D, intersection. Oh, okay. Now, in a linear figure, rectilinear figure, like I said, it's called simple because it's two sides except the common point. They never meet each other. Okay. So, or they never cut each other. For example, this figure, let's name it figure one. Okay. This is figure two. Is an example of it. Okay. While you see the second one, okay, it is not a simple linear figure. Why? Because the lines or its sides are cutting each other. Okay, so it's not a simple linear figure. I'll write this so you can write it down. Example is figure one. Okay, one is a simple linear figure, and the second one is not a simple linear figure since the sides are cutting. Simeon, it's okay. If you are unwell, you can log out. Okay, you can watch the live class later on YouTube. If you've been really feeling down, it's okay if you don't attend, okay? Have you all written it?
No, just give me a minute.
Okay. Sure.
Now, what is this word you have written after accept common point, do not after this one?
Except common point. Do not cut each other.
Okay. Done, ma'am.
Done, ma'am.
Okay. All right. So now what we'll do next is take a look at these two figures. I've already started receiving some formulas in the chat. Yes. So I have a square ABCD, and a triangle ABC. Okay. Two plane figures I'm having. Now, what I'll do is I'm going to shape them. Okay. I'm going to shape their region. Okay. Now, the region that I have shaded in both the figures, okay, the region that I have shaded in both the figures is known as the area of it, okay. That is basically the area of those plane figures. Now, we have, like in the first, we have a square region, okay, and in the second one, we have a triangular region, okay. So, we can say that the region bounded by a closed figure of a plane is called region of that figure, and its measure is called area of that closed figure. Okay, can you see that this region that I have shaded is inside a boundary? It's inside that figure's boundary. Okay, it's inside AB, BC, CD, and DA. Okay, so it is a closed figure. Okay, and the region that is inside the boundary, all the region of that plane figure, that is known as its area. All right. Any doubts still here? When we are calculating the measure of this region, okay, we call that area. Okay, its measure is called area of that closed figure.
Done, ma'am.
Done. Okay. Everyone has written? Okay. Next, we are going to see
Yes,
what
ma'am.
is, okay. Next, we are going to see what is the standard units of the measure of area. Okay, what standard unit do we use to measure the area of the plane figures? Okay, now when we measure the line segment, okay, what are the measures do we use when we are measuring the line segment? Can anyone tell me? If I have a line segment, what measures do we use to measure it? Hendrik,
Yes, ma'am.
what measures do we use to measure a line segment?
Ma'am, centimeter.
Okay, good. We have centimeter and
Millimeter, meter.
very good, millimeter and meter. These are the three things that I used. Okay, where while we are measuring the length. Okay, the length of a line or a line segment, we use these three standards. Okay, for bigger lines, meter. For very smaller, millimeter. Okay, then centimeter is also there. So the three units we use, okay, centimeter, millimeter, and meter. Now, similarly, when we are measuring the area of a plane region, okay, it's measured in square units. It's measured in square units. Okay. Now, how is it measured in square units? Suppose again I have a figure. Okay, I have a figure. This is its length 5 centimeter and here 3 centimeter. Name it.
Ma'am, the area is 15 centimeter
Very
square.
good. That is right. The area is 15 centimeter square. So what we do, we're gonna divide it. Why here 3 lines? Because we have the breadth 3 and the length 5. One, two, three, 4, and 5. Okay. Now, what is the square unit? What is one square unit? If I take one box from it, if I take one box from it, okay, this is exactly one square unit. Okay, unit square basically. So it is a small box. Okay, writing it here, and it has the length and breadth 1 centimeter, 1 centimeter, 1 centimeter, like this. Okay, this is known as unit square. Okay, unit square. All right, and If I talk about its area, okay, area that is length into breadth is 15 into 3, that is 15 square unit. Okay, and what is the unit here? What is the unit?
One
Centimeter.
centimeter.
Yes, 1 centimeter. Okay, 1 centimeter. This is the unit. Okay, unit of measurement. So if my length is given in meter, what unit of measurement I will use? Meter. Okay, square meter. All right, with the area. If it is in millimeter, mm, that is millimeter, what I will use as the square unit? Area 15 square millimeter or millimeter square. Okay, mm square. All right, so let's find out its area. We have area of rectangle equals to length into breadth, that is 3 into 5, which is 15 centimeters square. Okay, this is basically the unit of measurement. Okay, unit of measurement. Any doubt till now? Till here?
No.
I can ask. Done writing?
Yes, ma'am.
Okay. So today we did an introduction of this chapter. We learned about what are plane figures, okay? What is the area? What are plane regions? Okay, and about the standard unit of measurement of area. Tomorrow, we are going to talk about the perimeter of rectilinear figures, okay? Then we will learn about the area of triangle with the help of graph, area of triangle using formula, basically about the area of triangle. Then we
Ma'am,
have perimeters. Yes, Edric.
tomorrow the test or no?
Tomorrow the test is there, like after tomorrow, okay, in this coming week.
Tomorrow test or Wednesday? When is the test? Tomorrow.
Can you repeat that?
Ma'am, when is the test?
When is the test? Tomorrow. It is tomorrow, okay, of the circle chapter. 3rd December, I think I've posted it in the group of the circle chapter. Test is tomorrow. So after the test that is in this following week, we are going to talk about all these topics. We have the perimeters of rectangle or square, Then we have the areas of rectangle, of square, parallelogram, of trapezium. Okay, and after that we have the circles topic. Okay, so we are going to cover all of that in the coming week. Okay, we'll stop the class here, today's class, and
Which
we'll
test is
discuss
tomorrow?
which test is tomorrow. Simeon, test of the circles chapter. Okay, the that is I think
Okay.
your 14th, yeah, 14th chapter. Let me once see. Yes, 14th chapter. But if you still feel unwell, you can do it day after tomorrow as well. Okay. Yes. So the 14th chapter test will be tomorrow, so we won't be having the math class tomorrow. All right. I'll be sending the test at 3 p.m. afternoon. So we stop here today. Please prepare for the test well. Okay, Andrik, see you then. Bye.
Bye, ma'am.
Bye. Okay, a 5 minutes break for you all, and then we will start with the science class. Okay, let's begin. Can I have your videos on, please? Yes. So we'll discuss about the test queries. Okay. Any doubts or queries if you people have from the science test that I took recently from the motion chapter, you can ask.
Did you send the results for that one?
Did I send the results for that? No, I went through your papers, but I'll be sending the results, I think, by today. Okay. Any doubts regarding any of the questions? If you couldn't understand any questions or something.
No, ma'am.
Okay. Okay. So there was one question that I wanted to discuss with you all from the test. Okay, it was the last question. One box was there. Okay. One box was there. Two boys were applying were applying force on it, force to push it from opposite directions. Okay. They were trying to push it. Okay. In opposite directions. The question was that if the magnitude of force applied by both of them is equal, then will the box experience any force of friction? Will the box experience any force of friction? This was the question. What do you all think? What do you guys think will happen? Will it
Yes,
experience?
ma'am. It will experience force of friction.
Okay. Any other answers?
The box is experiencing force of friction, although it is in static position, because force of friction is like when two objects from different positions. Sorry, because the force that must be exerted in the opposite direction of movement to stop motion is known as friction force, and that's what is happening here. Two
Okay.
opposite two opposite forces are coming together to stop the
Okay.
motion.
Mm-hmm. Okay. All right. Any other answers? Abraham and Samir?
So there would be no question. Okay.
No friction. Oh, all right. Mm-hmm. No friction. Okay, I think I went to Simeon's copy as well. No friction. Okay. Now, what will happen exactly? Okay, two forces will be applied here. Okay, or two types of frictions will be applied in this situation. Now, since the boys are applying forces of equal magnitude, okay, equal magnitude from opposite directions, okay, so the net force acting on the box will be zero. Okay, why? Because both of these forces they cancel each other out. So the box is not going to experience any acceleration and it will not move. Okay. Since it is not moving, there will be no force of kinetic friction. Okay, first thing that's gonna happen is no force of kinetic friction. Like Abraham said, no friction. Okay, why? Why no friction? What is exactly kinetic friction? What's this kinetic friction? Now, this
Ma'am,
kinetic friction,
and it is like friction that is working.
yes. Now, it is also known as the sliding friction or dynamic friction. Okay, a force that opposes the motion of an object when it is sliding or moving against the surface. Suppose if box was moving in this direction, okay, kinetic friction would be applied in this direction, okay, in this direction. So it occurs when an object is motion and it is in contact with another surface. Okay, it's coming in contact, moving with another surface. Okay, so this kinetic friction is caused by the interaction between the object and the surface it's moving against. Okay, so what happens now? What happens now? As the object moves, the surface it is in contact with exerts a force that is opposite to the direction of motion, which slows down the object. Okay? This is kinetic friction. So the first thing is no force of kinetic friction. But the second thing that happens in this scenario is that static friction is there. Okay? There is still maybe a force of static friction acting on the box. Okay, but this force only is applicable only if the box is stationary. Okay, and the force that both the boys are applying is not sufficient to overcome the static friction. If the force is sufficient to overcome the static friction, then the box will start moving and kinetic friction will come into play. Okay, static friction ends and the kinetic friction will start to come into play. Okay, now see. What is static friction? I'll explain, okay? Now, static friction force basically is that force that opposes the initiation of motion between the two surfaces that comes in contact with each other. Okay, like
Ma'am,
it is a friction. Yes, Abraham asked.
I don't think you ever thought of the static motion or kinetic motion at all, ma'am.
Can you repeat?
Ma'am, I don't think you thought of static friction and then kinetic friction, ma'am. I haven't thought of that, ma'am.
I haven't taught us. I
Because
didn't taught you.
I don't see,
Yes.
I don't see any mention of that. Then how could you
Yes.
do a first time record? You
Yes, Abraham.
require
Yes, I get your point. Mm-hmm. Yes, I get your point that I didn't exactly taught you the exact kinetic friction and static friction, but in the questions I just asked you all, will it experience friction or not? Okay. So you just had to answer with a yes. Okay. That like because if the box they are pushing, if it will experience friction, yes, or because the box is not moving at all, no, it will not experience friction. Okay, I will not cut marks if you haven't mentioned the names. Okay, that is the thing. All right, I wasn't like expecting you all to mention the kinetic and static, but since we have that in the test, okay, I want to I'm explaining this to you because you so that you know okay these types of frictions so that you can understand that what is the friction called when two things are moving and an object is moving against the surface, what is that called, and what does it really like does friction comes to play when an object is in static, what is that thing called. Okay, since it was there, the concept was there, I'm explaining you all the concept. Okay, so now moving on to the static friction. What happens in the static friction? It occurs when an object is stationary and an external force is applied to it, but the object is not yet moving. Okay, listen very carefully. When an object is stationary and external force, this is the external force that is being applied to the box. Okay, but since the force is of same magnitude, okay, since the force is of same magnitude, the box is not yet moving. Okay, so static friction is responsible for keeping an object at rest, even when the force is applied to it. Okay, can you see that this object is at rest? Okay, it's not yet moving. All right, so this friction is responsible to keep an object at rest even when a force is applied to it. This force of static friction it increases as the applied force increases. Okay, now This static friction, understand this, increases as the applied force increases. Okay. Static friction increases as the applied force increases. Now they increase, and there is one point that is where it comes. It's known as maximum value, where it reaches the maximum value. Okay, the applied force exceeds this maximum value. The object will start to move. Okay, suppose the force, applied force from this direction is greater. Okay, this direction is greater than the static friction. Okay, the static friction force, applied force means the pushing is greater. Okay, then the object will start to move. Once the object will start to move, static friction ends, kinetic friction begins. Okay, static friction ends and kinetic friction starts. All right, that is the movement. Okay, so but right, one thing, no force of kinetic friction, but static friction forces there. Okay, static friction force is in play. Okay, so this is the thing that happens. Why I'm telling you these terms, okay, so that next time if such a question comes, you can use the exact terms. Okay, you can use explain the kinetic friction. Okay, that is when two objects are that is applicable when the two objects are moving against each other. Okay, that is in opposite direction. It happens kinetic friction. When an object is at rest, not moving, but external force is being applied on that object, but it has not reached the maximum point of applied force. So it is still in rest. That time which force is applicable? Static friction. Okay. Hope this thing is clear to you all. Both the types of forces, kinetic friction and static friction.
Yes.
Okay. All right.
Yes.
So, okay. Okay, good. So, this is about the last answer. Any other doubts from the test? If you all can just go through the paper. Any other question that you could not understand or anything, you can ask. In this test particularly, I kept a lot of questions with examples where you had to explain giving examples. You have to explain using examples. Okay. So that you know actually that in real, how do those things work? Okay. How does that friction is applied? How that force is applied? Okay. So I added give an example. Okay. Because we should know that in real, how is that force working? So that when we are seeing things moving in our real life, we are able to identify that oh, this or that force is applying in this situation. Okay, okay. So let me open the book once. Give me a minute.
No, no, I don't have any other doubts.
Okay, all right. So the next upcoming test that we people are having is of the chapters 18 to 20. Okay, from the chapters 18 to 20. We have the 18th chapter that is about natural calamities and disaster management. We have done this. We have done the air currents. Okay, this diagram is also you have to learn about it. Okay, about how the air currents are produced. Okay, this is how the air currents are produced. It's diagram different zones we have. Okay, and how the direction of the air is changing. I'll put the diagrams in the group. Okay, I will put the if we have any diagrams from these three chapters, I'll share them in the group. Then water cycle diagram also. This is also important. Okay, if the question comes on water cycle, it can be asked along with a diagram. Okay, so please do the water cycle diagram too. Then we have the bad effects of flood and drought. You can do that. Then thunderstorm and cyclones. Preventive measures. Okay, very important. Sometimes like preventive measures are also asked. Okay, give preventive measures against that one should take against an earthquake, against the thunderstorm. So do all the preventive measures. Okay. Then process of converting thunderstorm to cyclone. Preventive measures to learn the harmful effects of cyclone we have. Okay. Then earthquake and its causes. This movement of plates diagram is not quite important, but the internal structure of Earth, this you should know. Okay, the internal structure of Earth, this you should know. All right. Then safety measures for earthquake, please do. So this chapter you please prepare. Then we have the next chapter that is natural resources one, physical resources. Okay, meaning air we have elements of air. Okay, or the composition of air. A short question can also be asked on the composition of air. Okay, then utility of oxygen and carbon dioxide. What is its importance? What is air pollution? We have all the resources. We have water. Okay. Then sources of water is also a question that is important. Okay. What are the sources of water? Okay. So you should know about all the sources. That is underground water, glaciers, ocean, lakes, ponds, and rivers. Five major sources are there. Okay. Then water cycle again is it's there. How to make water fit for drinking are the various methods by which we can use to make water fit for drinking. Please do. Water pollution also. Then water conservation. Okay, this is also an important thing that you can do. If you want, you can do the water conservation tank diagram. Okay, this is up to you all. Okay, water conservation tank diagram. If you want to do, you can do this. All right. Then we have soil. Okay, layers of soil, please do. This is important. Okay, layers of soil diagram. Types of soil also please do. Then relation between soil and crop, soil erosion, we have soil pollution, and then mineral elements we have. Okay, coal, petroleum, and natural gas, and conservation of the resources. So this is how you will be preparing for this chapter. And then one more chapter that is natural resources to biological resources. So when you're preparing for the biological resources, um, main things that you have to prepare are the food chain. Okay, please prepare the food chain. Please prepare also prepare the food webs. Okay, you can prepare the food webs. All right. When this is gas balance in nature, I'll try if I can find the English diagrams of these. I'll be sharing them in the group with you. Okay. Then structure of forest. No diagrams from the structure of forest. All right. Organisms and plant species. Scientific names. Okay. You might want to ask me that you have to learn the exact scientific names of all the trees. But of all the trees, it's not necessary that you are to learn all the like 10 to 15 like scientific names of trees. No. But yeah, two to three you should know. Okay, so that you can give example while you are answering the question. You can give example. All right. Two to three, any that you find easy, you can do. Okay. Then food chains, I said that you need to prepare 1 or 2 food chains. Effects of weather and climate, please do cutting of forest in sample effects also. Then we have conservation of forest. So that's it from this chapter. All the three chapters, the combined test will be there. Okay, from all the three chapters. So please do that. Also, hope you all have started preparing for our half yearly exam. That's gonna be like in the last week of December and the 1st of January. Okay, please prepare for that as well. The 8 chapters that are coming from both science and math subjects. Prepare for that too. And if there are any doubts that you are facing in any of those chapters or the other chapters too, just ask, okay? Let me know anytime. So that's it. Any thing that you want to ask? Anything else? Any doubts
Ma'am, so the
regarding the
chapters are 18, 19, and 20.
yes, Anaya, 18, 19, and 20.
Then what about the 17th chapter test?
What about 17th chapter test? What's the 17th chapter?
Light.
Light chapter. Light
Yes, ma'am.
chapter test I'll take separately.
Okay. And when is the test of these three chapters?
When is the test of these three chapters? I think I've mentioned the date of 10th December.
Which is next week, right?
Next week, yes. Next week. Okay, so week you'll have to prepare
Okay.
for all of the three chapters. Okay, prepare for it. Any other doubts? Anything else? No?
No,
Okay.
ma'am, that's it.
Okay. So Friday we'll be having a PTM, okay, with sir. So please tell your parents we'll be having a PTM at it will be like after the maths class. Okay, 8:20. 8:20 finish with the maths class. After that, we'll be having a PTM. Okay, we'll be discussing if your parents have any doubt regarding the exams, regarding anything, regarding what's next. Okay, they can ask, right? So please let them know. Yes, and I am.
On Friday, right, ma'am?
Friday. Friday at 8:20.
Okay.
Okay? Yes. Also, you all can suggest me what experiments next we can do. Okay. After this, think about it today. Tomorrow, you all can suggest me what experiment we can do tomorrow. Or no, not tomorrow, like in the coming week, in this week or the next. Okay. Bring your suggestions. If you all have any suggestions for any activity, that also you can bring. Okay. Shall we keep a diagram test this Friday or
But
later?
no, ma'am, later.
Later. Okay. Okay, then diagram test I'll be taking later. Okay, but any activity or something that you want to do, you can suggest, okay? Okay, then that's it for the class today. Yes, Anaya?
No,
Ab-
yeah, later.
okay, Abraham, want to say something? Okay. Okay, then that's it for the class today. See you all. Bye.
Bye, ma'am. Thank